Okay, so yeah, welcome to the stream, I guess. We're going to be doing some programming. I'm going to show you all basically what avenues I take to create my own engine when programming in Java. I'm using the Eclipse here, as you can see, and yeah, we're just going to go ahead and start. First thing I'm going to do is I'm going to make a class called, when I can spell that is, engine. Put this into the packet of engine, of course, and then I'm just going to create. That's not quite what I wanted to do, but that'll do. I'm going to also make one called game, and I'm going to go ahead and put that into com. Now, what we're going to do in game first is we're going to extend engine, and we are going to extend engine, but we have to extend. Make a constructor here called game. What we're going to do is we're going to create a super constructor here, 800, 600, 1, engine build, that's build, engine build, 0.0, and did I need to put anything else in there? That should be it for now. That hopefully will be it for now. So it automatically include that engine class for us, but we're just going to have to create the constructor here. I'm just going to call this width, height, and WHS, sorry. And let's start. Let's just share that stream now. So yeah, this is what we're doing in the engine class now, and this is taking a while to work. This dot width equals W, this dot height equals height, this dot scale equals S, and this dot title equals T. I didn't rename the string here, but we're going to do that now. And obviously we are going to need to make up here our different classes. So we're going to make a private integer called width, height, scale, and then a private string that we're going to of course call title. That should sort all that out. Right, next thing we're going to go and do in this constructor is make a dimension called D, and to make this equal a new dimension of width times scale and height times scale. We're then going to do that this dot set min. Okay, sorry about that. Right, so we're just going to get back to it. So now we're going to go and do set dot this dot set minimum size, D, set maximum size as well, to also equal D, and also last one is we're going to do set preferred size. Now obviously it's not going to recognise this, not that I don't know how to spell preferred, but still that will work I guess for now. Because what we are going to have to do here is extend canvas and implements runnable, like so. I always forget to put the S on the end of extends. That's fine. Extends runnable. Does it have to go to a new line? I'd rather it not be on a new line. It's not wicked. And we are going to have to implement unimplemented methods, like so. Set preferred size. It's a double R apparently. It's fair enough. We're then going to do that this dot frame equals new JFrame with title in it, and this dot frame dot add this. So what this is doing is just setting up a new field now called JFrame. The reason we stored the frame at the top is so that we can change the title. That's the main reason I do it. So I can put my FPS into the title rather than having to run it and doing it separately. So that does that, and then we're adding this to it because this is a canvas. And next thing we're going to do is this dot frame dot pack, this dot frame dot set resizable as false, that's false as false, this dot frame set default close operation. Now this time we're going to do this as gframe dot exit on close, this dot frame dot set visible to be true. Now this should be everything I need. No, last thing I'm going to do as well is this dot frame set location, choose relative to, and then just put null here. That will just center the thing on the center of the window on the screen. So what these do in order is it makes a new JFrame with the title of what we've allocated it has, adds the engine to that, packs it so it makes it the right size, sets it so that it can't be resized, sets it into the middle of the screen, sets that when we close that window it will close and exit the game, and then set it to set the visibility to true. And now what we should be able to see in here. Now all we're going to have to do, so this game thing is what this game class, what this is going to be is this is what we're going to want to have to do every time we make a new game. So the idea of this is that the engine class you can in the end put into your libraries, and then that way you'll just be able to make a new game by what's in this game class, which you'll see in a moment. So the last thing we're going to have to put into this just to start this up is a public static void, and we're going to call this main, and then put into it a variable, and I'm going to call mine args. You can call that whatever you want, obviously it's just a variable name. I always go for args, it's a nice simple one, obviously short for arguments. In here we're going to make a new engine, no we're not, we're going to make a new game, and like so, and actually that should be it now. If we now run this, you get a window on the screen like so. Nice and simple. So this is all the code we're now going to need to be able to put an 800 by 600 thing on the screen, because obviously all of our engine part is all at the back here that we're not going to even see when we're making a new game next time. So the next thing I'm going to do in here is just put g.start. Now this is going to be the start point of your game, not set drop target. This is going to be the start point of your game. Now in here we're going to make a new public void and call it start. Make sure you do this into the engine class obviously. Now what you're going to do is set the if running, then we're not going to do anything else, which means it's not running. What we're going to do is do a new thread made using this, and then we're going to start that. And lastly, we're just going to set running to equal true. This way, we're going to make sure that we're not creating the same game running again and again, or creating a new thread starting again and again in this one game. Now I can run this now, but to be honest with you, it's not really going to do anything for the moment, because in this run function, which is now what's going to execute, nothing's happening. We need to create a game loop or something like that. So what we're going to go do here is while running equals true, and I don't even need to put the equals true there. We just need to put while running. And lastly, what we're going to do here is make this protected. The reason we make running protected is we can now set running to be false from this class, and it will affect this one. So we can close the thing from within it, so we can put like an exit button on the screen or something like that. In here we are going to, now this is the interesting bit, because this is where a load of variables come in and you're just going to have to bear with me. So we're going to make a long here, and we're going to call this this time, no, we're going to call this now, and this is going to equal system dot get current time. going to equal system.nanotime. We're then going to make another long called last time, and that's just going to equal now. We're going to make another long here, and we're going to call this time per tick. This is going to be right. It is 1 followed by 9 zeros. I think that should be what that is. Here it is. 1 followed by 9 zeros, which I believe is a billion, depending on where you're from. I think it's the American billion. I can never remember, but that is the time per tick. Next, we're going to make a few variables here. We're going to make a long called time since tick. So you've got time per tick and time since tick. Set the time since tick to equal 0, and the tick timer, or what should we call this? We'll call this a tick counter. We'll equal that to 0 as well. Last thing I'm going to do is just set some integers. So you're going to have int called ticks and frames. Okay. And actually, you probably should set both of them to equal 0 as well. In here, which is the while running, you're now going to put now equals system.nanotime. Okay. And then what we're going to do is now start testing. So if what you're going to do now is time since tick has to plus equal now minus last time. This just counts how long it's been since the last time it looped, and what we're doing here is we're just making sure that we limit how many frames we're going to run this at, because obviously we don't want to be running this at 60 frames per second and then it's actually coming out closer to, you know, like 60,000 frames a second. Okay. So that's that. We're then going to test if time since tick is greater than or equal to time per tick. Now what we're going to do is we're going to tell it to tick. And then once it's ticking, we're then going to do ticks plus plus, which just increases ticks by 1. And then we're going to do that time since tick minus equals time per tick. Now, I've played around with doing this to setting it back to 0, and I don't know, I think it all depends how it runs, because the problem is with this is if it comes out that there's something wrong with it. So if there's something wrong with the code and it goes into like a debugging mode, it will stop the code for now. When you come back into it, that variable is going to be really high. I'm just going to move the mic down a bit. Yeah, that variable is going to be really high, and so sometimes you might want to set it to 0, but in my opinion it's not all the time that you want to do that. Add cast to long. So it cannot convert from double to long. Really? How many doubles I think? Can they be doubles? Yeah, they can just be doubles. Right, so now what we're going to do is this one. If tick counter is greater than or equal to, that's our 1 followed by 9 zeros, once again our billion. And then just copy and paste that. So what this is doing, this is counting how many ticks we have a second, because that 1 billion is 1 second in them variables. So what we're now going to do is do that this dot frame set title, and here the first thing we're going to put is title, and then we're going to add, now this time we're going to add a little bit of text. We're just going to put a space, just a line like that, and then put another space, add ticks, and put another space here, and another line after another space, and we're going to do that like so. So now what that code does, it just sets the title of the frame to include the tick rate and the frame rate. You'll see that in a moment when we actually run the thing. The last thing we're going to do in this bit is ticks equals frames equals 0. This just sets the ticks and frame counter back to 0. And in here what we can do is frames plus plus and render. Do I want to use render or do I want to use draw? We're going to use draw for this bit. I'll explain why in a moment. But yeah, that's what that's going to do. So now when we run that, you should get this sort of... Why aren't you getting a loop? Maybe is the loop running? So let's... A good way to debug, just so, is just to use this function here. All this function does is just prints true into a console at the bottom of the screen, which you can see there it does. I know why. Because here you're going to put that the last thing you're going to do in this loop is just set that last time equals now. This way this just tells it what the current time is, so that when it loops back again it can tell how long now has been. And apparently it is not doing that, so we're going to go back in and put the true thing into the function, into the loops time, and it is looping. Let's put time since last tick in here, and that is changing. If I put ticks into here now, it's okay. I've just realised, like as I was doing that, what I'm doing wrong. I haven't even told it to increase time tick count like what we've got down here. Fine, I do that. Hopefully we should. Yeah, there we go. So now you can see we're running at 60 ticks per second, and that's like 52, 53 million frames per second. So that's pretty good. Pretty good.